Hello, folks. So, welcome to part 36 of Learning Rust series. This is part of my 100 Days of Rust, and I'm on day 16. So, the last exercise that we looked at was the enum 1. So, I'm just going to go ahead and remove this I'm not done to look at the next exercise that we have. So, we have enum 2 now. Okay, these are some old messages that are coming up. So, can I do a help, clear, maybe, do this. Okay, and say I'm not done. Okay, so this. Okay, so now it's all clear. So I'm just gonna go ahead and do that. Cool. So now we have a clear screen with all these things coming up. No variant in move. Found for the number. Okay, so we have a lot of 5005999 again. So this is for enum2. So let's go ahead and read that up. No hints. Okay. I mean, if you want hints, you can read it from here. So two implementations. One is the debug and the other is the implement message call. Message is unknown. Okay. And then the size is 4. Okay. It's an array of fixed size. So there's nothing called move, echo, change, color, and all. So we'll have to define the different variants below. So these are all associated functions, variant or associated functions. So just gonna go ahead and define. Actually, these are all functions. These are all okay. This is not struct. I should not forget that. Interesting. So struct had your usual function and whatnot. I guess here also you can have that. So you can have your move or say quit, and then you can have say function call. Oh, this is message and messages. And then call. Okay, interesting. So call is going to be a self thing. So that's clear here. Oops. Um. Hmm. What does this say? It's one argument. Interesting. So this is an unknown type because this is not determined. So echo. Can I say function echo? Say string, and then have this, right? What is the type for all these though? Like you say call, I don't know, like change color, I don't know. Hmm. So function change color. Okay, this is like RGB things. I'm just gonna go ahead and put red, green, and blue, and yep. So with that, what does it say? Should have snake case. Example echo. Okay. Okay. So I don't get this. Expected one argument, found 0. Okay. Interesting. Variant move not found here. Okay. Hmm. So I think I remember seeing this one-off type, right? Primitive types. There was one interesting thing in primitive types, like there was enum where we were able to have arrays. So arrays, let me look at slices or arrays. Okay. What are the exercises that you completed? Enums. If I think we did collections, variables. quiz. Okay. Functions. Using different functions, modules, no semantics options, standard library types. Nope, I don't think so. Strings. Oops, no, they haven't come here. Threads, traits, vectors. Interesting. I guess we haven't come here at all. Let me go ahead and look at the list of exercises that I've done. So quiz one, variables, intro, primitive. Okay. Enum one is also done. So I'm just gonna go ahead and look at. I'm wondering where they store this information. Gitpod, replit. Target tests. Git ignore. Oh, target is basically the place where they're having it. Cache directory tag. Interesting. So looks like this is used by cargo and the information about this is here. And debug. Interesting. And then we have temp. Okay. Incremental. And then rustlings. Wow. So that's basically the rustlings binary, I think. So file. Yep, that's the rustlings binary. And then fingerprint examples. Okay. So not file, ls. Interesting dependencies. Cool. So interesting thing is you can see C001 something like that, many of them. Cool. So now debug spell. Okay. So this is for debug. That's all, huh? Interesting. Let's git ignore PDB. What's PDB? Star.pdb. Interesting. Anyways, I don't remember looking at some other stuff here, like, I don't know. So rustlings list. Let's basically look at, say, primitive types, all the 6 of them, and then move semantics maybe, or even functions, and see where they take us. 3, 4, 5. Nope, I don't think so. These are the ones. So let me go to primitive types. Primitive types 1, 2, character, 3, array, 4, mix of arrays, right? Like there was one thing, right? Primitive as vectors. I think it was vectors, huh? Nope, it wasn't vectors. Move semantics, structs, interesting. Variables, maybe. Variables, 2, 3, 4. Interesting. I remember seeing something around that. Anyways, in type enum. Okay, interesting. Iterator 3, box 1, hash map, errors, enum 3, enum 2. Interesting. There aren't much stuff for here. Any of something? There was some mixed type thing anyways. I'm just going to go ahead and check out what it means for one to actually create a associated function to an enum. So I'm just going to go ahead and like look at learn and go to read the book. And do I have enum, pattern matching, common collection and storing? Any enum stuff here? Enums and pattern matching. Oh, we're defining. Okay, so let's look at enum and pattern matching. I think here we're looking at chapter 6, which is here. So we're looking at enums. In this chapter, we look at enumerations, also referred to as enums. Enums allow you to define a type by enumerating its possible variants. Okay. Excuse me. So first, we'll define and use an enum to show how an enum can encode meaning along with data. Okay. Now we'll explore a particularly useful enum called option, which expresses that a value can either be something, can be either something or nothing. Look at how pattern matching in the match expression makes it easy to run different code for different values of an enum. Finally, we'll cover how the if let construct is another convenient and concise idiom available to handle enums in a code. Cool. So how do you define enums? You just put enum and then say define the different values. We call this function is either variant. Okay. Mm-hmm. Mm. Hmm. Have even more done it. Think about more about it. Okay. Hmm. So I'm just wondering. So this is giving an initial shower representing the same concept. Let me read the whole thing. Where structs give you a way of grouping together related fields and data. Okay. Like fields and data, not like a rectangle with its like length and breadth or like height and width. Enums give you a way of saying a value is one of possible set of values. I mean, like makes sense. For example, you may want to say that rectangle is one of the set of possible shapes that also includes circle and triangle. Okay. To do this, Rust allows to encode these possibilities as an enum. Let's look at a situation we might want to express in code and see why enums are useful and more appropriate than structs in this case. Okay, so say we need to work with IP addresses. Currently, two major standards are used for IP addresses: version 4 and version 6. Okay, because there are only these are the only possibilities for an IP address that your program will come across. You can enumerate all possible variants, which is where enumeration gets its name. So any IP address can be either a version 4 or version 6 address. Okay, IPv6, IPv4, but not both at the same time. That property of IP addresses makes the enum dataset appropriate because an enum value can only be one of its variants. Both version 4 and version 6 are still fundamentally IP addresses, but it should not be treated as the same type. And the code is handling situations that apply to any kind of IP address. Okay. Um, Okay, so we can express the concept and code by defining an IP address kind, enumeration, and listing the possible kinds of IP addresses that can be like V4, V6. This is now a custom data type that we can use elsewhere in our code. So we can create instances of each of the two variants of IP address kind like this. Note that the variance is of the enum as an and its identifier means double colon to separate the two. Okay, this is useful because we are now both values are of the same type, IP address kind. We can then, for instance, define a function that takes IP address kind. Okay, so route and then IP address kind, and we call this function with either variant. So IP address kind like V4, V6. Using enums has even more advantages. Okay, thinking more about IP address type. At the moment, we don't have a way to store the actual IP address. You have, like, you just say it's the type, right? Data, IP address data. We only know what kind it is. Given that you just learned about structure, you might be tempted to tackle this problem with structures shown in figure 1. So struct and then kind is IP address kind, and then address is IP address basically. String, and then that's all. Here we have defined a struct IP address that has two fields, a kind field that is of type IP address kind, And enum we defined previously, and an address field of type, and the enum we defined address field of type string. We have two instances of the struct. First is home, and and it has the value before as its kind associated address data. Um, of okay, with associated address data of advantage. Second instance is loopback. Okay, colon one IPv6. Which are used in an address value. So now the variant is associated with the value. Okay. However, representing the same concept using just an enum is more concise rather than an enum inside a struct. You can put data directly into each enum variant. This new definition of the IP address enum says both v4 and v6, and variants will have associated string values. Okay. So, like IP address value. So it's v4, then you give the v4 IP address v6. So we attach data to each variant of the enum directly so that there is no need for an extra struct. Here it's also wise to see another detail of how enums work. The name of each enum variant that we define also becomes a function that constructs an instance of the enum. Ah, okay. Okay. So I guess this is called change color. I'm guessing you just have to do this, and then you just have to do echo. Interesting. Move. Just have a struct. Oops. Either do. Cool. That's pretty cool. I think we have it working now. Let me see. Enum expected enum message found. Okay. So okay, so echo should give an enum message. So I think I'm just gonna go ahead and like just do this. Cool. They're all of type message, and one is a type that picks up values. So here you can see there's no need to. Next one here is also easier to see another detail. Name of each variant that you define also becomes a function that constructs an instance of the enum. Okay, so each variant name becomes a function that constructs an instance of the enum. That is, 4 is a function. Okay, so colon v4. Cool. So you create, and the type is basically IP address 4, IP address, and then it's v4, and then this is the string. This is a function call that takes a string argument and returns an instance of a variable. Say this we automatically get this constructor defined default as a result of defining the enum over here. There's another advantage to using an enum rather than a struct. Each variant can have different types and amounts of associated data. Yeah. So version 4 type address will always have 4 numeric components that will have values between 0 and 255. We want to store a v4 as 4 values, but still express v6 addresses as one string. We wouldn't be able to do it with struct here. Enums handle this case in this case and handles this case with ease. So now you can say IPv4, do it this way. It's a function taking up all of this. What about the struct like stuff? We've shown these several different ways to define a store version 6 IP addresses. However, as it turns out, wanting to store IP addresses and encode what kind they are is so common that another library has a definition they can use. So let's look at the standard library like how the standard library defines IP address. It has the exact enum and variants that you define and use, but it embeds the address data inside the variance in the form of two different structs. Okay. It's IP address, IPv4, so v4, IPv4. Okay. So now your move is basically that XY thing. So, but it embeds the address data inside the variance in the form of two different structs, which are defined differently for each variant. So now you can say it's any of something like that. In TypeScript, you can say any of. So this code is says that you can put any kind of data inside variant, strings, numeratized structs, for example. Include another enum. Also, standard library types are often not much more complicated than what you might come up with. Okay. So I'm just going to go ahead and probably stop here and maybe come back when I'm more awake because I'm feeling sleepy. It's pretty late, so I'm gonna go ahead and sleep and then come back probably tomorrow on another video. But for now, I think we're good to go and like, it's all passing. Um, I'm gonna actually continue this tomorrow and read through this from around here. Yeah, cool. That's all I had for this video. See you in the next one. Bye.